Okay, so what we are going to do is we're going to plot Math 20-2. So this is marks from last semester. These are people who took 30-2 who had taken 20-2 last year, right? Because they had used first semester. So in this column is their 20-2 marks. That's this column. And in this column is their 30-2 marks, right? And we want to see if there's a relation between them. Okay? So we're going to graph those on a sheet of graph paper. Like this. So we're going to need to come up with a scale. So what scale might we be able to use for this? Tens. I think we'll use tens. Now, one thing though, before you do that, so having learned a little bit something this morning, because I did this morning, is what we'll do is let's put our 0 about here for that, and this will go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And we'll put the 0 there. And 100. And the reason we're doing that is when we draw our line of best fit, it might be that it comes down through here, right? And we need to be able to see the y-intercept because we want to get an equation for this. Okay, and that's why we're going to put our 0. So this will be the math 30-2 mark, and the x values will be the math 20-2 mark. Okay, and away you go. So start off your bottom axis, your x-axis, which is your independent variable, is the math 20-2 mark, and your y-axis, which is your dependent variable, we want to see if the 30-2 mark depends on what you got in 20-2. Do you think it will?
No, it wouldn't.
No, it wouldn't. Okay, well, we'll find out.
Well, why are we starting with 0 here?
Okay.
Just use that.
Shall I rewind the tape a little because I explained it? Okay, so one more time. We have a scatter plot, right, that we have graphed. And then we've drawn the line of best fit. We're going to find the y-intercept, that's B. We're going to take 2 points on the line and use them to calculate the slope. So this is not what I wanted to write. This is x2, y2, and this is x1, y1, and that's your slope. And then you're going to get an equation in this form. Okay, who has an equation they want to share?
What was yours? Oh.
I don't have one, right? You actually are doing this, so.
I have one.
Okay, what's your equation?
0. That's.
No, that's nothing. That's garbage.
I want to follow that.
That's an example you could follow to get it. So.
0 minus 45. Never mind.
Never mind. Okay. Yep.
Mine was y equals 1x plus 1.
1x plus 1. Okay. Anybody else? So that's y-intercept, that's slope. Okay, anybody else got one? Just need a few. 1x plus 5. Anybody else?
1.38x minus 18.
Okay. So that's why we started the 0 out here, right? So yours went down like this. One more. Anybody else? 2.13x plus 0. Okay. So these equations, or the equation of a straight line that you could get, right, would be something that you could use to predict. Given a 20-2 mark, this line is describing what you may score as a 30-2 mark, right? It's not cast in stone by any means, right? It just says of these 21 people, this line of best fit, or the equation of it, allows us to make some predictions, right? We'd want more data than that, probably. So what we're going to do is we're going to pull out our calculator, and we're going to enter this information into the calculator. Okay, so I'll run you through that as soon as I can. I'm going to close that. And that. And let's get out the calculator, which has gone where? Up here. Okay, so here's what we're going to do. We're going to put this information in the calculator. So to start off with, go second plus, right? Because what we're going to do is we're going to start off by clearing our lists. And then let's throw in a 4 for clear all lists. And then we'll hit enter. So it says done. Okay, we've cleared out the list. We're going to enter the what we're going to call the independent variable, the 20-2 mark, as the x values, and the dependent variable as the y value. So we go to stat, edit, and in L1 we're going to put our x's, and in L2 we're going to put our y's. Okay, so you can do that now. And I'm just going to do it from here. I'll beat you guys.
No, you wouldn't. Oh no.
Yeah, and what were you saying?
I entered the number wrong.
Yeah. So again, what were we saying about who's going to finish first?
61st, 64. You're blocking our view.
Ah, see, that's why I'll finish first.
Come on.
All right.
Yeah, you're gonna finish first. I can go. Yeah, someone beat you.
Yeah, but you won't.
Yeah, because I keep making mistakes.
Yeah, okay.
66.
Ah, damn, I'm off. Okay, so good lesson here, right? I missed one of the numbers, so I just need to go back and check. You know, like I got a 65, I got a 64 with a 75, so I missed a number further up, which is a real problem because it just means I got to keep re-entering it.
Yes.
50
I
should
beat
be.
you.
Yes. 6, oh wow, where did I make my, okay, so the 70, 72, 62, 73, so that should be a 79. 63, 45.
Oh no, I missed.
Okay, so your list should be the same size. And having messed up, I almost did that on purpose, not quite, but if you have to do one of these on a quiz or a test or an assignment, or go back and check your numbers, okay? Because it's easy to type 660 instead of 60 or something like that, right? And the thing is, if it's multiple choice and you make a mistake, you're probably going to find the answer, because you won't get one of the answers that's there. If it's numeric response, you're going to get an answer, okay? But you want to go back through and just check your list, and you can either, you know, just go over and just run down the list again. And what I would do is look down here because it's a bigger number, right? And then just go through and check them. I'm not going to. I mean, we'll check each. Oh, but there's one there, right? Underneath the 77 should be a 70. So you can see how it's easy to. You know what? Let me just leave that as a 7 because I'll show you what happens when we go to graph it. Okay? And then I'll fix it later. Okay, what we want to do now is we want to draw the scatter plot, just like you did on paper, on the grid paper, right? So here's how we're going to do a scatter plot. First thing we're going to do is we're going to go set our window. So we're going to say 0 to 100 by tens, and 0 to 100 by tens. Okay, so we're going to set a window and let our x values go from 0 to 100 and y from 0 to 100. And we're going to go turn on the stat plot. So go second y equals to take you into the stat plot menu. Plot 1, turn it on. Make sure plot 2 is off. We had it on the other day, so it might still be on. And then you can hit graph. And if you notice, I've got this 1 point sticking way out here, which we would call an outlier, only it's not a real point, right? I mean, nobody got 7 in 20-2. You can't do that. You wouldn't be able to go on, right? So then I got to go, oh, darn, I made a mistake. I can hit trace and just arrow over until, arrow over. Why won't you let me arrow over? No, arrow up and down, okay, so. Okay. Never mind. Okay, so I'm going to go back to stat, edit, and I'm going to look for my mistake, and there it is. That should be a 70. Okay. And there's the graph, and it's. So does this graph look like your graph, the one that you drew?
Wait a minute. What?
Fairly close, right?
How did you graph this again?
Watch the video. It explains everything. Okay, so now we're going to put in a line of best fit, all right? So we're going to go to stat, over to calc. We're going to hit number 4. I want a linear regression, but then don't do anything. Don't hit enter or anything, right? So I want a linear regression. What I want to do now is tell the calculator where the stuff is and where to put the resulting equation. Okay, if it's in L1 and L2, which it is, then we don't have to tell the calculator any different. That's where it automatically looks. Okay, so it defaults to your x values are in L1, your y values are in L2. But what I want to do is take the resulting equation and put it into y1. Okay, so that it'll graph it on the graph. So I'm going to hit the vars key. And I'm going to arrow over to y vars. And I'm going to hit enter on function. And then enter again on y1. So vars, over to y vars, hit enter twice, it'll put a y1 there. So what you're telling the calculator is run a linear regression. In other words, I think my data should be a straight line, right? Because we look at the points, it's a straight line. Run a linear regression and take the resulting equation that you get and put it into y1, so when I hit graph, it'll show it. Okay, so we hit enter. It runs the regression. This is the equation we get. Is yours different? Yeah. Okay, so I have a messed up point.
0.9.
So I got to go back to stat and edit. So I need to go through and check my points. I got 63, 65, 58, 58, 65, 77, 87, 70, 75, 71, 82, 50, and 63. How about that? Is that yours?
No.
B is wrong.
Can I see yours, please?
I got more stuff wrong. 63, 65, 58, 56, 58. So this is why you should check your, I'm not doing this on purpose, but 71, 82. This is why you should check your values.
Max?
59, 62. 69, 66, 70, 72, 62, 73, 61, 79, 56, 63, 50, 45, 65, 70, 71, 67, 75, 65, 60, 50, 58, 67, 70, 74, 78.
56, 50, 60.
How about this?
Where'd you
Okay.
get Y one?
So we have an equation which is y equals. Let me write. Why won't you let me write?
Where do you get Y1?
Y equals what? 0.998 5.328. 0.998. So whoever said x plus 5, you're right, right? I mean, that's what it is, okay? And you couldn't get much more accurate. I mean, to be that accurate on yours is pretty good, right? Because this is, we didn't do it with any degree of accuracy. What does that look like? So if we hit graph, here's what it looks like, right? There's the graph, there's your line of best fit. Okay? So if your slope was off, I get the feeling you probably miscalculated. Like somebody had a slope of 2. I think you probably miscalculated as opposed to drew the line too steep. And I think your line just pointed a little bit down more than it should have, right? But that's a limitation of doing it by hand, right? I mean, you're eyeballing it, you got to plot the points. Doing it by machine, much more accurate. So this is predictive, right? And that means that we could say, well, okay, I got and you fill in the number, I got a 68 in 20-2. What will I score in 30-2? Or what might I score? So you go second, calc, number 1 for value, and you say, all right, I got a 68. Then I should get a 73, right? If it follows, if this is a decent model.
Where do you enter the
Okay, try another one. So second calc, value number 1. Say I got a 75 in 20-2, then I should expect an 80.
Yay!
Summer school marks don't count, sorry.
Oh, that's not fair.
Yeah, I know, but summer school marks aren't real marks.
They have real math.
No. They might be on your transcript, but. Now the other one is, what did somebody who got an 80 in 30-2 score in, well, okay, we know that. Let's change it. What did somebody, so what would somebody who got a 90 in 30-2 have scored in 20-2? So what we do in this case, right, because I don't know the 20-2 mark, I don't know the x, so we go to the y equals, and we say, okay, I'm going to make y2 90. Remember, my y values are my 30-2 marks. And I'm going to graph that. And what I want to find is the intersection of those two lines. So we go second, calc, intersect. And I'm just going to move up to about the point of intersection. Right about there. And then I hit enter 1, 2, 3 times. And we've got an 84.8, right? So about an 85. So if you were going to score 90, then by this model, right? I mean, this thing means nothing. It's just a model. It doesn't mean that you guys can't get 90s. Well, I didn't have 85 and 20-2. I can't get 90. Sure you can, right? Because there's a person that had, what, 77 and got 87? Because really what this model predicts, y equals x plus 5, says just take your mark and add 5 to it. So it says, on average, the 20-2 marks went up by 5% in 30-2. Why might that be? What are some reasons?
Some of them decreases.
Yeah, some went down. But on average, they went up by 5. What would some reasons be that a 30-2 mark would go up by 5%?
Because you want to graduate school.
You want to graduate school, yeah. So.
University.
University, so you're actually taking this course a little more seriously. I know this counts. I know that universities are going to look at it. It's a diploma course. You're going to work a little bit harder at this. Then that's usually what happens in 30s. People work a little bit harder at a 30-level course than they might at a 20-level course, right? And that could explain why the marks are going up. Okay. You can also do this on a spreadsheet. Yeah.
Why is the speaker telling to us and not to you?
So here's the spreadsheet, right? And I asked the spreadsheet to do the scatter plot, so plot the points, there it is. I asked the spreadsheet to give me the line of best fit, there it is. I asked for the equation, there it is, right? Same equation we got. So the spreadsheet does the same linear regression, right, on this. And it's nicer because we can put nice little titles on there, 30-2 versus 20-2, and here's your 30-2 marks and stuff. And, you know, it's easier to see, and then there's a scale on the side, so you can say, oh, okay, well, this poor person only scored 45 in 30-2, right? But they're still a diploma exam. That's their school mark. All they need to pass is probably pretty much to pass the diploma. Okay. If you end up with a 48 average overall, they'll usually bump that to a 50.
They will?
They will.
At the diploma exam?
Yeah.
They're so generous.
Yes, they are. But if you end up with a 47, they might not bump it. So,
come
first of all,
on.
you don't want to be in that. You want to be up here. You want to be going in with a high school awarded mark. You know, like 70, which means, oh, I need 30% to pass, right? Because, you know, 30%, you know, you got to score at least that. I mean, nobody's going to score that low on the diploma, right? You're going to do better. Okay, so we did it by hand. Problems with accuracy, you probably want to try to eyeball the line of best fit to see it. We did it with the graphing calculator. Allows us to then make predictions, right? If you go second count, number one value, you can put in an X value. It'll tell you the Y value. If you have the Y value, you go Y equals, put that in as Y2, and then find the intersection because you're interested in the X coordinates of the point of intersection, which is this value here. Okay, any questions?
No question.
No questions. Right, so we're pretty much done, right?
Yay!